Also freue ich mich, dass wir heute hier haben André Hirsinger von Neofonie.
André Hirsinger from Neofonie is here. Thank you, Daniel, for the kind introduction. Welcome to my presentation and welcome to this wonderful location today. We're not in Berlin, we're in Duisburg. In Berlin, it's a bit difficult to kind of take off, airports in particular. So we're going to talk about highly scalable online shops with Shopware. It's going to be a bit technical. I hope that's okay for you. We have to kind of look at some details as well. I try to make it as simple and understandable as possible. But before I start, let me introduce my company, Neofonie. We develop e-commerce solutions, of course, including Shopware. And some of these businesses you see here, semantic search, big data analysis. I don't really want to elaborate on that. Briefly introduce the company to you. So we have been, or we attend to the whole project, i.e. starting from the idea, the implementation, and then go live and operate the shop. As to the services we provide, hosting and operation are our focus today. Of course, we are a full service provider and we offer a lot of other services. We're going to talk about an online shop, an online pharmacy. This is the homepage. Now our task is to design a simple shop, but it's quite interesting in terms of its scalability because it has a few features which are not necessarily standard applications for Shopware. Let's take a look at this. We have project requirements. And I'm going to use this example to explain how we implemented this. This is a specific, this is an example of a specific project. Of course, we wanted to build the shop system on the basis of Shopware. We expect high availability, i.e. 99.9% basically. So we want to have 0% downtime, i.e. 100% availability, ideally. And we want to have scalability. Often you apply Shopware as a standalone or single instance systems on one server or one instance. Let's see whether we can do something else. And there's something else which is a bit different from a user who simply visits an online shop. We wanted to implement this so-called box campaign or box promotion. It's like a sales campaign. You have one particular product at a very attractive price. The campaign starts on a certain date. So it will be, that date will be announced and the user wants to buy the box on a Friday morning at 10 o'clock. So from the online shop's perspective, that's a disaster because you have all users at the same time visiting the shop. So let's see how we implemented this. The last one is actually the most important one, and it applies to any project. A few facts and figures. We have about 250,000 products. So at peak times, we have to process about 200 orders. So we get about 2,500 hits per second. Any technical experts here? Do you know these dimensions? Do they tell you anything? So this is not exactly huge. You don't associate it with a huge cluster, but at least it's a bit more than what you would implement on a single instance or server. So in this case, the provider had a kind of certain status and wanted to make sure that the current status or the next status would already accommodate some future feature so that you can actually update or scale up the program. I'd like to show you the standard Shopware architecture. Many of you are familiar with that. So apart from Apache, we also have Nginx. Of course, we use PHP. And then we have a MySQL database. You can use other versions, but that's a standard that I will use for this example. And we have some optional components that are aimed at boosting performance. Of course, the product search, which you source out to Elasticsearch. And of course, the caches, i.e. the administration of individual sessions, like Memcache, Redis, or ZendOP cache. So these can actually accelerate these processes. You can implement it on a single instance architecture. That would be the first step. But you can actually go beyond that. You could have a distributed architecture. So just leave aside these ugly gray designs or images. So I have various systems on which I need to distribute my application, but need to make sure that the deployment also works. It's not necessarily beneficial to think even bigger when you think about 10 or maybe even 20 instances. Well, the limitation of the standard installation is a static allocation of the instances. You need to know where your database is located. You need to configure it. That's more or less static. And it's not that easy to automate that. You have one database instance, and I'm going to explain why this is important. And you have these nice-to-have cloud features, so you don't want to have individual VMs, but you may want to have a management system that would make things easier. So that's the first step, the architecture. So of course, let's take, I took Shopware off the shelf. I know what the system performs, how it's to be installed, but how can I actually have these box campaigns or promotions and generate higher traffic? There's no two ways about this. You need to really look at the specific situation and analyze what is happening. You can do that with a number of tools. Has anyone of you tried to see, how the performance is doing? Have you conducted analysis as that? So the kind of headache this may cause, and it's not that easy to extract this information. Well, I would recommend that you look at the database queries yourself. That is a very good starting point for the analysis. Then you have the processing time in PHP, and we use Tideways, a very good tool. So for every processing step, you get a timestamp and can see, what is happening over the course of time. The system utilization, you need to know that to determine the memory of your server, or a bigger hard disk or more hard disks. Of course, you need to test the whole infrastructure, which is an excellent or maps the user behavior very accurately. So you want to get the response times. And if you work with MySQL databases, there's a company called Percona, a US company, and they are dedicated to developing performance optimization tools. And if you want to learn more about them, just take a look at their tools. They deliver very good results. That's what it looks like. Those sitting in the back probably won't be able to read the explanations. This would be a load test with JBeter. Are you familiar with them? So which URL is represented by the yellow line? Each line represents one URL in the shop. And this is the account login. This is the yellow line, where you can see response times of about 7 seconds. So you know that you need to look at that and probably optimize the PHP code. This is an example of Percona MySQL analysis. You can see the I/O, the number of queries, and also queries without database index. Of course, it's imperative to look at these data when you want to establish the performance or the scalability. This should always be your starting point, really. You might have a cluster that is infinitely large, and cost is not an issue, so then you don't really need to consider carefully. But those who have to pay for their server capacity, for them it's rather interesting. In the case of this shop, we had a problem with a number of select queries, particularly when selling these campaign items, these promotion campaign items. So we need to be sure to parameterize. We don't want to have one database instance, but we want to have be able to access our data pool, and we had a little problem with the PHP processing time. So any content that wasn't cached slowed down the system immediately. So when you want to install various instances, what's the best way to manage them? When you install a system on the hardware, the system would then be in a VM, and when the system is installed in the VM, it will be part of a cluster like Kubernetes or Docker Swarm, and then containers are started in this cluster, and you no longer administer VMs. So our solution includes the container cluster technology, because we will not be able to manage it without container clusters. The container structure has other requirements like deployments, which you can then easily automate, which is a nice side effect. In our company, we didn't really use the Dockers to really upscale the operation, but simply because we needed a new deployment, which was earlier than installing Docker, and it was for the reason of deployment. And we have a number of new features that make it easier to manage the system, like auto-recovery and auto-scaling features, which makes such a cluster operation our first choice. Have you actually used such a Docker Swarm cluster? It's not really an obstacle. I just tried to illustrate what this looks like. It could be Docker Swarm, but it could also be Kubernetes. I just wanted to show you that you have one side where the containers are running and one side where you have the cluster status, which is the management, basically. It may put you off at first glance if you're not familiar with that, but there are projects also in Kubernetes and also big hosting providers, for instance, Amazon's hosting. There are new projects to simplify this kind of management. So a few years ago, it was not that uncommon to develop a cluster like that. So working with that, there are really very few obstacles to working with that. We looked at the architecture of Shopware, what we can improve, and of course we have the Kubernetes cluster. So how does this fit in with Shopware? We separated the backend and the front end. So we have a dedicated query, and that makes it possible to work with the response of the system. Even other things are running on the front end, or there's a load peak which slows down the system a little bit. The distribution of the queries is done by a Galera cluster. It has a very nice replication feature, and we use any caches and optimization tools that we're familiar with. And this would be the setup. We use the Kubernetes cluster. This makes it possible to integrate new services quite easily. We do not only need the software function, but also infrastructure components like an SSL offloading, and this can easily be integrated in this architecture. That's what it looks like in reality, and you may say, well, it looks exactly what we saw before. Not really. The management function of the Docker Swarm or the Kubernetes cluster, you need to specify where you're going to run the services, and then you run the services, and then you can restart them. But that is managed by the cluster. On the left-hand side, you see the Shopware backend. Let's say for some unknown reason, it dies or the entire node is down. We actually restart it. You don't need to do anything. You just need to configure that. So I'm going to do a bit of advertising for Docker Swarm and Kubernetes. It's not that difficult. I think it would work if you just copied and pasted that. Let's say you started Docker Swarm with docker init command. Then you would have a WordPress with a database. The two systems would be able to communicate with each other. And you might actually use replicas 3 and restart policy always. Then you've started several instances, and they would automatically restart if they're down, if they crash. What are the benefits? So you have a simple deployment with Docker images. Are you operating any installations that use Docker images for deployment? Oh, that's great. There are quite a few, actually. We have achieved a scalability through several Shopware instances and several database instances. The database instances are a separate story. It's not delivered with a cluster. It's the Galera software, the MySQL software. And you also have additional features like a green-blue deployment That means an ongoing update will be subsequently run on the front end, and a user who uses the front end actually sees that a user who uses an older version may still see the old feature, but actually that happens in parallel. And these cluster solutions make it possible to add new resources on demand. So, for instance, a new node. If you find you need more processing time on the front end or more CPU, you start a new node and a new front end will be initiated so that it's easier to process the load. And now I'm going to cover some technical details, I'm afraid. So when you look into clusters, of course, load balancing is an important issue. I just wanted to show you how we've done it. So we use classical load balancing, which could be hardware in a computing center. Or if you started the instances in Amazon, it would be the elastic load balancer in Amazon, which needs to locate the individual nodes, i.e. the nodes in your cluster, but does not have any information about the services. You could actually have all the services as AP or something else, and then you would have that and distribute that to the different nodes. So this means you're in the cluster world then, and in the world of Docker Swarm, where you have automated processes and start separate load balancers that would query the services. Traffic is an interesting solution. You actually attach a label to the container, and when there's a host request, you use the host header with that name. It will automatically find the container and query the container. So classical load balancing in combination with automated load balancing in the Swarm cluster. But you can incorporate other services. You also need SSL offloading. You want to have a shop with HTTPS. And there's this specific feature here. Now it's becoming more interesting. So we had to implement this promotion. This is an image from Berlin, a shopping center called Alexa. A MediaMarkt opened its store, and they have the same problem. You see the number of customers wanting to get into the store, and they don't open the doors entirely. So it's not possible for all people to enter at the same time and have a stampede, basically. So we do the same technically to actually have a solution for this campaign. On a Friday morning at 10 o'clock, there is an announcement in a daily newspaper, and at 10 o'clock all the users will be there, and then you get an alarm. We've uploaded a system that has a controlling mechanism so that each user gets a time slot, a session, is able to start shopping, and 70 or 80% are then put into a waiting line, and they will have to wait. It sounds a bit drastic. Why not use a system that would give access to such huge traffic immediately? Of course, we would love to do that, but let's say you have 10, or you want to sell 10 or 20,000 of these boxes in a minute. It would be feasible, but then you would have to have such a campaign every hour, and you would have to have this number of users every hour so that it pays off.
So we said, okay, we'll do it this way. People might have to wait 5 minutes, and then they can buy their box. We're wiring everything into our cluster. via a simple configuration of services. And in this example, you can see how finally the traffic is shoveled through to the front end, the Apache front end. And then there we have the possibility of opening or closing the gate a little bit more or less. And this is the result. This is what it looks like. I don't know whether you can read it on the top left in our log file evaluation. I was looking for the host and the URL checkout confirm. So we do have a look at what the sales were like, and this is briefly after 10, where you can see that it starts. On the left, we have a peak 300 sales per minute, and with this traffic limiter, we can make sure that the sales are distributed over a certain period in the same way, and they're all successful. So the user comes in, logs in, and can safely buy something, and the users after that also enjoy the same shopping experience. And without the traffic limiter in such a box action, would probably make sure that there are error warnings, and it's not really nice for end customers to be faced with something like that. So we can have a look at the technical details if you like. What kind of components is everything based on? And this is a bit more comprehensive now. If we cluster databases, then this is not for free. If you set up a database cluster, you have 3 nodes on which you can run the database queries. But you still have the problem, what do you do if one of the nodes is not there? Or if you want to maintain the cluster, you have to start an additional node. You need to be able to control all that. And then you need an additional component in the entire system. That is the DB proxy, which I inserted on the left. So it's an HA proxy, which can help us to control which node will be addressed. And you need that when you plan to migrate a cluster to the next higher level. If you have maintenance periods, you quickly need these additional components. Galera clusters might be known to many of you. The most important features are that you can write in parallel on all nodes. Whether you always want to do that, I don't know. It's a nice feature. But there are different opinions on this. So if you write on several nodes, it could happen that if this cluster is then separated into 2 parts, you have to combine it again. And if there's a lot of orders per minute, then this can be very difficult. So it might be smart to have separate write processes just on one node, and the read processes can be split up. So both is possible, and we've both implemented. An automated synchronization can happen if you configure the Galera cluster right. If one node is lost, if you start a new node, it takes exactly as long as the transfer of the files, and then the node is in sync and works again. And that works very reliably. We have very few problems, also very few problems with configuring the system. And we also needed an additional control element in between for maintenance periods. Sorry. Now, the clustering of Shopware instances. I only wanted to show you the 2 main elements you have to deal with and what to do about them. It's very nice to have 4 different Shopware instances, but how do you maintain the data and where is it stored? Media data, for example, on the left, which need to be replicated. And you could also say that you have a central storage, an NFS, a central form of storage, whatever. We decided against that. As long as the data volume can be handled, it's best to deal with it in a stateless manner. So we synchronize the data. Later you might have the problem that the data volume increases and you can't do that anymore, but usually in the area of shops that's feasible. And then it's very beautiful because the front ends really are independent. But the synchronization needs to be established. It's an additional container service here that does the synchronization for you. It's an rsync protocol, which it is based on. Then there's a second problem, which is not trivial. You know that the page doesn't look good, you do an update, CSS is broken, pictures are missing, then you need to delete the cache. You can do that, but the problem is that it happens on the back end and the front ends still have the old data and it's still not nice. So for that we created a cache hub, an additional container service, which makes sure that the entire system, the back-end instance and the front ends can be deleted, the cache can be deleted. It's not that complicated, but an important hurdle to take. Caching is good, but you need to be able to get rid of the content also. So what do we need? We need media synchronization, a mechanism which helps us to make sure that the caches are deleted. And it was also helpful to have a dedicated backend. So editorial work control in the shop is also feasible when the front ends are busy doing something else. And we do that with different host names. Now we have this big cluster and everything's up and running. How did we get there? Well, in our case, it was a very demanding project. And with regard to technology, Docker, Swarm, Kubernetes were reasons why we wanted to have a new deployment. That's a project that was a bit longer. We learned quite a lot of things, and the system is very nice now, but it has an additional level of complexity. We also introduced a new technology. With Kubernetes, you can do quite a lot of things. If you have many projects and large installations, you will tend to rather look at that. If you only have one shop, which you run on one server, it seems to be a bit further away. At the entry, the technology level is becoming less and less of a hurdle. It becomes more and more comfortable to use. There's the Amazon Kubernetes service, for example, where you can have a cluster with the management functions, with the cluster updates and everything that goes with it. You can just buy it like that, but it will take some time. Amazon announced it. It will certainly be launched this year. And then new technologies that have to establish themselves in the market. So you can use it, but as soon as you're not the only one using it and it's used in a company, then these technologies can be used for quality assurance, in the deployment, and it can take a while until it's up and running successfully. You also need additional tools. So you get a whole fleet of other tools that can be a bit scary to start with, but a lot of comfort goes along with it. So if you get used to it, it becomes very easy and simple to use, and then you don't want to live without it anymore. And here too, the entry hurdle is less and less of a hurdle. So wanting to use a cluster, the special knowledge you need, that becomes easier and easier. And Docker is a big Lego module box, and everything that's available online is also quite mature yet. Now, in conclusion, let's talk about the great benefits and what we think were the positive outcomes of our project that will be interesting in the future too. That's a high reusability of the components. The traffic limiter I showed you could be used in just any other project with very little effort, because it's really like a modular toolbox. Then new instances can be set up quite quickly because no installation is required, or very little setup time is required. We can also test features in quality assurance, start new instances if you have a shop with a host name and an associated database. With our Jenkins system can just be created with a press of a button, 5 minutes testing, and that's it. We're hosting provider independent with our cluster system to a very high degree, and everything is easily portable. And the outcome of this project is that we have a very high level of automation, which is the key to quite a lot of other projects, and that's the current status. In conclusion, always remember, if you've taken a picture of the moon, it's not that easy. You put your camera up there and the moon has moved. It's a moving target. That's what I wanted to say. Thank you very much for your time. Thank you. Well, thank you. There are certainly questions from the audience. Wait for the microphone, please. Hello. What about the licenses? If I have a large number of clusters or machines, I might have a license problem. Well, they're limited with the number of hosts, and we're in contact with the company. This high dynamic system, it's very difficult. We started to number some of our clusters, not until 100, but 1 to 20 suffices. And for the plug-in activation, we always needed the licenses. You need to talk to Shopware. There are solutions, but generally, yeah, that is an issue. Two things. Is there a big difference between Galera, that you don't use a master-master relationship? Well, a master-master installation would be possible. Then you'd have 2 nodes, or you could add one additional one. With the different technical approaches, we particularly like the replication of the Galera cluster. So we have a replication that is very comfortable and very fast. The InnoDB data file was to be replicated, and we preferred that solution. But we could also have a master-master replication in MySQL. But when you have to recover the node, there's a bit more work involved. So reintegrating a master-master configuration is a bit more difficult. And the licenses, we've never noticed that because we use a reverse proxy for that. And we have a mirrored load balancer. Well, these are not the licenses you need for the live system for operation. We just started test systems, and they are just numbered as test system 47, 48, 39. We just needed them for the environment. You don't have to buy them, really, because you have a project that's up and running, but you need to integrate them. You need the code which needs to be integrated and activated. On the new deployment, I have a question. Is it based on 5.4 with Composer? I can't see who's talking. Okay. We do it with the Shopware 5.4. And the composer functionality, do you use that too? So via the composer, you can add new instances? Yes, you have to get used to that. If you build Docker images, if you have a Jenkins automation of the images provided, and then the composer is at the status and its log file as in the moment when you open it first. So you should not integrate things in the release that were not tested before. So you need to be very careful with that. So the current status is the one at the time you open the composer. Other questions?
Gut, dann würde ich sagen, vielen Dank auf jeden Fall. Wenn ihr
Okay, thank you very much. If there are any additional questions, you can certainly grab the speaker and discuss things in even more detail. Thank you.